At 2 minutes past 10 in the morning on the 27th of August, 1883, a volcanic island in the Sunda Strait tore itself apart. The sound of it was heard in Perth, in Western Australia, 1,900 miles away. It was heard on an island in the Indian Ocean, nearly 3,000 miles away, where the men who heard it assumed it was cannon fire from a ship over the horizon, and made a note of the time. It is generally held to be the loudest sound in recorded history. More than 70% of the island of Krakatoa collapsed into the sea. 36,417 people died, by the official count of the Dutch colonial administration. Almost none of them were killed by the volcano. That last sentence is the reason this belongs in this series, and it needs saying twice. About 1 in 10 of the dead were killed by pyroclastic flow, by the volcano behaving as a volcano. The overwhelming majority were killed by water, waves that reached 150 feet at Merak, 140 on the west coast of Java, 79 on the south coast of Sumatra, coming ashore into villages where the people had spent 3 months watching an eruption and had no reason on earth to be looking at the sea. The official story tells of an eruption so violent that nobody could have survived it, and nobody could have seen it coming. What the records reveal is stranger. Everybody saw it coming. It had been in plain sight for 3 months. It was surveyed, photographed, and reported, and the news of it went round the world faster than news had ever gone before. And all of that produced not one evacuation. Begin with what was visible. Krakatoa did not go off without warning. It began erupting on the 20th of May, 1883, and it went on erupting in a manner anybody could see from a passing ship for over 3 months before the day that killed everyone. The Sunda Strait was one of the busiest waterways on Earth. It is the gate between the Indian Ocean and the Java Sea, and in 1883 the traffic through it was continuous. Mail steamers, tea and coffee ships, coal, colonial administration, telegraph repair vessels. Every one of them passed within sight of a mountain that was throwing ash and steam thousands of feet into the air. They watched it, and there is no ambiguity about this, because they wrote it down. Ship's logs from that summer record ash on the decks and the sound of detonations across the water. Passengers came up to look. Ash fell on vessels 100 miles away and was collected and kept. In Batavia, 80 miles off, the windows rattled in their frames often enough that people stopped remarking on it, which is a sentence that appears, in one form or another, in every story this channel has told. On the 26th of May, less than a week after the eruption began, an excursion party was got up and taken out to the island so that people could look at it. That is what it was. A day trip to a volcano. They went ashore. They walked on it. They came back and told people about it. It is easy to read that as recklessness, and it is not. In 1883, an erupting volcano was, for anybody standing on a ship at a safe distance, one of the great sights available to a human being. And the distance that counted as safe was understood to be small, because the thing being kept away from was falling rock. Through June and July, the activity continued and the observations accumulated. And in early August, a Dutch topographical engineer, Captain H.J.G. Ferzenaar, went out to the Krakatoa Islands and did a proper survey. This is the detail that should be held on to. A government engineer, 3 weeks before the event, went to the volcano with instruments and made a map of it. He recorded 3 major ash columns and a great number of smaller vents. He noted that the ash was thick enough on the ground to make walking difficult. and that vegetation was gone. It was competent, careful, professional work. It went into official hands, and it did not lead to a single person being moved off a single beach, because the map answered the question that had been asked of it, and the question was about the island. So set the state of knowledge on the 1st of August, 1883, plainly. The volcano was known to be erupting. Its condition had been surveyed by a government engineer. The survey was in official hands. Ships were passing it daily and reporting on it. The nearest towns, Anjer, Merak, Telok Betong, were a few tens of miles away across open water. They were on the coast, and they contained tens of thousands of people. And nobody moved anybody, because there was nothing in the world at that moment that connected a volcano to a wave. This is the part that has to be got right, because it is the difference between this story and the other 6 in this series. At Johnstown, a letter existed, and somebody had filed it. At Peshtigo, the condition was so constant that it stopped registering. In 1888, the warning was written correctly in St. Paul and never reached a schoolhouse. In 1925, the word was forbidden. In 1900, an entire country's forecasts were banned by law. In 1964, the message went to the wrong desk. All 6 of those are failures of transmission. Somebody knew, and the knowing did not arrive. Krakatoa is not that. Here the transmission worked perfectly. What failed was the category. The danger was fully visible, continuously reported and correctly described as a volcano. And a volcano in 1883 meant lava and ash and falling rock, which meant that the danger radius was the island. The people at Anjer were 25 miles from Krakatoa across water. By the only mental model available to anybody at the time, that made them spectators. There was no theory that said a mountain could displace enough sea to drown a coastline 40 miles away. That physics had not been assembled yet, and so 36,000 people stood on the correct side of a danger that had been mapped by a government surveyor, and were killed by a mechanism that was not in anyone's list of things a volcano does. Now the telegraph, because the telegraph is what makes this event modern. In 1883, the world had just finished wiring itself together. Submarine cable ran from Europe to India, from India through Singapore, from Singapore down to Batavia in Java. Roughly 2/3 of the world's telegraph line was in British hands. For the first time in human history, a thing could happen in the Sunda Strait and be known in London the same day. And Krakatoa is where that was proved. At 47 minutes past 3 in the morning on the 23rd of May, 3 days after the eruption began, the Lloyd's agent at Anjer put the news of the first explosion onto the wire. It went by landline to Batavia and by submarine cable to Singapore, and from Singapore, it went everywhere. Hold on to that image, because everything about this story is inside it. A shipping agent in a small coastal town, at 3:45 in the morning, telling the planet about a mountain. Through the summer, the cable carried the story onward as the eruption continued, and by the time of the great explosion in August, newspapers on 4 continents were following it. When the island destroyed itself on the 27th, London knew within hours, not within weeks, as it would have known about Tambora 68 years earlier. Hours. This is the first disaster in the history of the world that the whole world learned about while it was still happening. And it saved nobody. That is not a rhetorical flourish, and it is worth being precise about why, because the reason is structural rather than moral. The network was built to carry commerce and empire. Its lines ran from the colonies to the capitals. Anjer could talk to Batavia, and Batavia could talk to Singapore, and Singapore could talk to London. And none of that describes a route from Anjer to the village down the coast. The information traveled outward from the danger at the speed of electricity, and it traveled toward the people standing in it at no speed at all, because nothing had been built to point that way. There was also the matter of time. The waves that killed the towns of the Sunda Strait arrived within tens of minutes of the explosions that generated them. Even a perfect local network would have had almost nothing to send, and almost no time to send it in, because the thing that would need warning about had not yet been recognized as a thing. The cable at Anjer went dead that morning. So did the town. The 27th of August did not happen all at once. There were 4 great explosions, and the first came at 5:30 in the morning. The second was at 44 minutes past 6. Each of them displaced sea, and each of them sent a wave into the strait, and the towns along both coasts were being struck by water for 4.5 hours before the one that everybody remembers. The third explosion, at 2 minutes past 10, was the one that took most of the island with it. The lighthouse at Fourth Point, at the western tip of Java, was taken off its foundation. Anjer was destroyed. At Merak, the wave came ashore at 150 feet, higher than anything most people can picture, running up a hillside and taking everything on it. Teluk Betong, on the Sumatra side, was struck by a wave that carried a government steamer more than a mile inland and left it sitting in a valley, above the town, upright. That ship stayed there. It was still lying in the valley decades later, and photographs of it became the standard image of the disaster. An iron vessel in a green landscape with no water anywhere near it, which is a thing the eye refuses at first, and then has to accept. The great explosion at 2 minutes past 10 produced a pressure wave that radiated outward at 675 miles an hour. And here is where the story stops being about a volcano and starts being about the planet. That pressure wave went round the world, not in a poetic sense, in a recorded, instrumented, timed sense. It passed over Calcutta and Vienna and Washington and Melbourne, and in each of those places, and in dozens more, there was a barograph, a clockwork drum with a pen resting on it, drawing the atmospheric pressure hour by hour, in an observatory or a university basement, doing nothing but keeping a line. Every recording barograph in the world caught it. The pen would be tracing its ordinary flat line, and then it would kick, a small sharp step over in a few minutes, and then go back to normal. Nobody at any of those instruments felt anything or heard anything. The wave that made the mark had already crossed thousands of miles of ocean and was continuing on. Then, hours later, in each of those same places, it happened again, and again. Some barographs registered the passage 7 times over 5 days. 4 of those were the wave traveling outward from Krakatoa. 3 were the wave coming back, having gone all the way round and returned from the other side. It is worth stopping on that number, because it is almost always got wrong. 7 registrations does not mean 7 circuits of the Earth. It means the wave rounded the globe 3.5 times before it faded below what the instruments could see. The 7 marks are 7 passages over a given station, outward, returning, outward again, not 7 laps. The distinction gets flattened in almost every retelling, and it matters because the true version is stranger than the exaggeration. A single sound had gone round a planet and come back to where it started, 3.5 times, and left a legible mark on paper each time it passed. Nobody had ever measured anything like that. Nobody had ever been in a position to. The instruments existed because a generation of scientific societies had spent decades installing them and insisting that somebody write down the reading every day, in places where nothing ever happened, for no immediate reason at all. Most of those records are the dullest documents ever produced by human beings. A flat line, kept for years. And then one afternoon in August, every one of them, in every country, wrote down the same event. And this is where the institution appears, and for once in this series, it appears at its best. On the 17th of January, 1884, the Royal Society in London, under its president, Thomas Henry Huxley, resolved to form a committee. Its purpose was not to explain Krakatoa. It was to collect it, to gather the accounts and the instrument records from wherever in the world they existed, and put them into a form that would preserve them and make them useful. That committee went out and asked. It gathered barograph traces from more than 50 stations around the globe. It collected tide gauge records, sound reports, ashfall observations, and the accounts of the colored sunsets that appeared over Europe and America for months afterward, and that people at the time could not explain. The report came out in 1888, edited by G.J. Simons, and it is one of the strangest and most impressive documents of the 19th century, because it is the first time anyone assembled a single physical event from measurements taken all over the world. Out of those 50-odd paper traces came real physics. The speed of the wave, measured across the planet. The behavior of pressure waves in the atmosphere at scale. The confirmation, in ink, that the air is not a set of local weathers, but one connected medium. That something can happen in the Sunda Strait and arrive, as a measurable physical fact, in a basement in Vienna. The dust did the same work in a different register. The eruption put an enormous quantity of sulfur dioxide into the stratosphere, and it spread, and average summer temperatures in the northern hemisphere the following year fell by 0.4 of a degree. And the skies changed. For 3 years afterward, sunsets in Europe and North America came in colors nobody had a name for. Reds that filled half the sky, green suns, a moon that appeared blue. In November of 1883 in New York, in Poughkeepsie and in New Haven, fire brigades were called out. Not to fires. People had looked at the western horizon, seen it burning, and turned in an alarm. Engines went out to put out a sunset. Nobody in those towns knew that what they were looking at was a mountain in the Dutch East Indies, 6 months dead and 11,000 kilometers away, hanging in the air above their heads. A volcano in the Dutch East Indies changed the color of the sky over London and cooled the whole northern half of the planet by a measurable amount. So Krakatoa is the moment the world found out it was one thing. It is worth saying what a strange kind of discovery. That is, nobody set out to make it. There was no expedition, no experiment, no hypothesis being tested. A mountain came apart, and 50 pens in 50 rooms on 5 continents moved a few millimeters. And 4 years later, a committee in London laid the papers side by side and saw that they were all recording the same morning. The proof of a connected planet was assembled out of accident and paperwork. Set that against the 36,000. The people of Angers and Merak and Telok Betong were part of the same demonstration. They were the closest instruments to the event, and what they recorded was total. And the network that carried the news of their deaths to 4 continents in a matter of hours had been laid past their doors without ever being pointed at them. There is a version of this story that ends by blaming somebody And this series has been willing to do that when the record supports it. Willis Moore and the Cuban cables, the 98 minutes in Sacramento, the word that was struck out of a forecast in 1887. The record does not support it here. Nobody suppressed anything at Krakatoa. Nobody softened a warning or misfiled a letter. The Dutch surveyor did his job and filed his map. The Lloyd's agent sent his cable. The barographs kept their lines. What was missing was a sentence that did not exist yet in any language. A volcano can drown a town that cannot see it. That sentence exists now, and the reason it exists is those 36,000 people. Volcanology treats volcanic tsunami as a standard hazard. The coastal geometry of the Sunda Strait has been modeled precisely because of what it did in 1883. The knowledge that would have saved them is knowledge that only they could produce. Which brings this to the 22nd of December, 2018. Krakatoa did not stay gone. A new cone grew out of the caldera and broke the surface in the 1920s, and it was given the name Anak Krakatau, the child of Krakatoa. It has been building and erupting ever since, in the same strait, on the same spot. On that evening in December 2018, a piece of its southwestern flank, a fairly small piece, less than a fifth of a cubic kilometer, slid off into the sea while the volcano was erupting. The wave came ashore on the coasts of western Java and southern Sumatra. 437 people were killed. There was no warning. Not a late warning, not a garbled one, none. And the reason is worth stating exactly, because it is the whole series in one sentence. A landslide does not produce the strong, short-period seismic waves that an earthquake produces. The tsunami warning networks that cover that ocean are built to detect earthquakes and to infer tsunami from them. A wave generated by a piece of a volcano falling into the water does not announce itself in the way the system is listening for. So the system heard nothing and reported nothing, and 437 people on a beach at 9 in the evening had no idea anything had happened until it arrived. 135 years after Krakatoa, in the same strait, by the same mechanism, with the physics fully understood and written down in the textbooks. And the machine that warns people was still not built to hear it. The sentence exists. It was paid for. It has not been wired in. There is a last image, and it is a small one. Somewhere in a European observatory on the 27th of August, 1883, a barograph drum turned as it had turned every day for years, with a pen resting on it, unattended, in an empty room. At some point that afternoon, the pen made a small step and then returned to its line. Whoever came to change the paper would have seen it and wondered what it was. That mark was made by 36,000 people dying 11,000 kilometers away, and it would be 4 years before anybody was able to say so. The mark is still there. The paper survives, in archives, with the step in the line clearly visible. The smallest possible record of the largest sound ever heard, drawn automatically by a machine that had no idea what it was writing down. Explore with us how other disasters reshaped the world that came after them.